Okay, hello and welcome everybody. Good morning.
Morning.
Good
Good
morning.
morning, Professor.
Morning.
Okay. So let's see, this is what, week 3, right? I think this is week 3. So let me share my screen.
Good morning, Professor.
Yes?
May I ask you a question?
Yeah, just let me share my screen, then you can ask a question.
Okay.
And, okay. Yeah, okay, what's your question?
Hi. Sorry. I am from Group 5 of
Yeah.
among the groups, and
Yeah.
I emailed to you about the problem that we had.
Problems that you had. Okay, let me just.
One of our members has dropped the course. Yeah.
Oh, right. Oh, okay. I didn't. Did you put that in the wait, did you put that in the, let's see, let me go to forum. And there's the forum. So this one, did you enter that in here?
Yes, I have.
Right.
If you want to check that.
Yeah.
I think it's comment number 4 or something. I don't remember.
I think I saw that. 1, 2, yes. And
There, Group 5.
Group 5 here, okay. Oh, but you didn't tell me who it was.
Oh, I emailed you about the person. I didn't write the name on the forum, of course.
Oh, I see. That might have been a problem for me. I mean, I didn't. Let's see. Let me look at. Anyway, yeah. So you're. Did I? I'm trying to find this. Where is it? Oh, okay. No. No. And where is that? No. I uploaded a new list of people, right?
Yes, I have seen it.
So, was your list, was your group changed or not?
Let me check one more time. It's
What's
not.
your group
It's still
5?
the same. Yes, Group 5. It's still the same.
Okay. Yeah, that's because I expected you to write the name of the person here, then I didn't see it, so
I'm so sorry.
I didn't change it. Okay, so we have to change that group. Okay, so
Any
if
possible?
yeah, of course. So if anybody else, let's see, I made some changes to the groups, but if this one I didn't change, it wasn't in here. So just if you're still haven't heard from your group members, then post up here the name of the people in your group, the person who didn't reply or that isn't in the group anymore, and I'll make new changes to the groups after class today. Okay?
Thank you, Professor.
Okay. Anybody else? Anybody else have a, I think maybe you're the only one, then I'm not sure. There were some other issues like that, but I made the changes to the groups. So hopefully everybody is in a group with people that are responding. So we will proceed with the groups as they are now, except for I have to make one additional changes. Someone just let me know. Okay, any other questions? No other questions. Okay. Let's look at the new homework assignments first. So let's look at assignments. And I guess I have to look at, how do I look at this? How do I do this? Is there some way to see it from your perspective or no? No. Okay. I thought there was. All right, anyway, we have some assignments. So let's see, what do we have? So we have some that are due. Here's a group project first Scrum. So this is just posted last night, and this describes what you have to do for your first Scrum. You have to do it with your team, and it's due on June 7th. So you have about 2 weeks, a little bit more than that, I think, to do it. And then we also have another Scrum forum assignment. So we saw there was a forum on Scrum here, but I asked for the people who haven't already answered here to do the homework. And so that is due soon. That's due very soon. Let's see. That is due on the 24th, which is Sunday, I think. Is that right? Sunday or Saturday? Let's see. 24th is Sunday. So that is due Sunday. So if you already posted to the forum, then just copy and paste that into this assignment. If you haven't, then do the assignment. And then after the due date for this, anybody who hasn't posted their comments or to the forum, take the homework that you did here and post that into the forum. Okay, so anyway, make sure that you get this done before Sunday. Any questions on those two assignments? So this one has all of the details about the first Scrum, the first version of your group project. So you can take a look at that. So just to, let's see, go through it maybe a little bit. You need to decide who's going to be the Scrum Master and note it in the paper that you write. And you can have two Scrum Masters, one for the first 8 days, one for the last 9 days, and make sure everyone knows what Scrum is about. And the Scrum Master should also give a report in this same group report. You should also give a report on what your activities were as the Scrum Master, and it should include dates and outcomes, and include this as part of the Word document. So this whole group project should be submitted as a Word document, and as part of that, you should mention the details of what the Scrum Master did. The group project details, you should be prepared to deliver your first version of your project on June 7th. And this should have 2 possible potential data sets that you will be choosing from for the final version of your project. So you're going to use 2 data sets for this Scrum, but then you're going to narrow it down to 1 after that. It should also say what the input and output variables will be and how many rows of data they have. Both data sets should have at least 15 variables or attributes and 3,000 rows of data. Each data set should be submitted as a separate Word file. So you're going to do the report on 2 data sets, and each one should be submitted as a separate Word file. The names of the Word files should be the group, like group number 3 or something like that, the data set name, Scrum 1, and your name. Every assignment should be submitted in Word. If you want, you can also attach PDF files, but I need Word in case I want to comment on them. Each member of the group should submit both files, so everybody has to submit it as homework, not just one member. Maybe after this first Scrum, we won't do it that way, but this one we will. Eventually, you'll choose just a single data set. For first Scrum, you'll work with 2. The first version should show various useful analyses, I guess it should say, done in the pre-process tab of Weka. So, Weka has different tabs. I guess I can bring this up. Let's see, can I do this? Can't seem to do it. I can't move my Weka. Why not? My screen is too small. Oh well, I won't show you Weka right now. Okay. That is the part where we see the graphs of the histograms of the various attributes. This should be done for both data sets. Use all the concepts and tools that we have learned in our class up to June 7th. You should state what the output variable is, what you're trying to predict, classify, and how this project could be useful and to whom it could be useful. Think of the stakeholder and what they would be interested in as a result of your project. Make sure to frame as much as possible in terms of stakeholder interests. The output variable must be non-numeric. Note that you can make a numeric variable non-numeric with a filter in Weka, so you can check this video. For example, if you have, suppose your output variable is temperature, so you're trying to predict the temperature. Well, that's numeric, so you wouldn't want to use that for this project, but you actually can, because you can take, let's say the lowest score in your data set is 5, and the highest score is 100. Then you can just break it up into ranges. So you could say a range from 5 to 14, another range from, or let me make it simpler. You could break it up into 3 categories: cool, medium, and hot. So, maybe cool is, I don't know what, maybe this is Fahrenheit, not Celsius, because 100 degrees is crazy hot, right? And centigrade. So maybe this is just, this is Fahrenheit, which is not so hot. Anyway, you could say cool was, say, between 5 and 15, and, or sorry, between 5 and, what would that be? 5 and 40, and then medium is between 40 and 60, and hot is between, or 40 and 70, or 40 and 80, and hot is 80 to 100. So you could break it up into categories, or you could do it like this: 5 to 14, you can have 10 categories or something like 10. Okay, so you can convert a numeric data to a categorical variable. Okay, and then more details about the deliverables. More details about the deliverables. Well, you should describe the data. What are the inputs and the outputs? What's the meaning of each variable? So to make it easier for the reader, you want to say what are each of the variables and explain them. And if you have more than 15, you can just work on just the 15 most interesting or most important, or whatever 15 that you choose. Show a screenshot of the data as displayed by Excel, or you could use RapidMiner. So it's just, that's familiar. Excel is familiar to everybody. So if you show the data in Excel, it's kind of, they sort of know what you're talking about it quickly. Or you can use RapidMiner. It's also going to give the same kind of display as Excel would give. Now, sometimes you have too many columns of data, like you have, suppose you had 100 variables and you can't really show it in Excel, but just show at least some of it in Excel. Analysis of individual variables with the color overlay, and what useful information can you get from analyzing those graphs. And do this for at least 8 variables in each data set. And in this Scrum, none of the machine learning algorithms should be discussed. That is, nothing from the Classify tab. And the graphics should have captions. So the way you do a caption in Word is you just right-click on it, and you right-click on the image, and it will bring up Add Caption in the menu here. and you just add a caption. Okay, so that is due on the 7th. And then, what else? Let's see, we have data translator. So you can read that. You're just supposed to look up this phrase, data translator, and figure out what it means and answer some questions. And WECA, this is closed, but this is the new WECA assignment here. So I think that's all just the new WECA assignment. Yeah, so the new WECA assignment is here. And we have some, let's see, repeated training, testing and training. Then we have something called baseline accuracy. And then we have cross-validation and something else, cross-validation results, simplicity first. Okay, so you can go through these videos and answer these questions. Okay, anybody have any questions about the assignments due from now? Okay, everybody's okay with that? Okay, so what else do we have? New group assignment. We talked about that. Here I posted the link to the past projects, so you can take a look at those and get an idea of what you need to do for the first Scrum. Anything else new here, group members? This is a book that's about WECA, but it's just the slides, I think. But you can look at the slides if you want to. Week 2. Oh, these I hope that you've watched these already. These are very important. So I hope you've watched these past projects. Okay. Anybody have any questions before we continue? Okay. Let me close this WECA and open it again. Okay. I think I will reshare my screen with you. I'll do it this way. Okay. Oops, can't do that. Okay. So let's take a look at some of these videos. So I asked you to look at these videos. So here we talk about, in this video, this was the first video, talk about how to analyze these graphs. So that's very critical to what you need to do for the project. Actually, just a minute. I just want to take a quick break here because I have a cough. Just want to get something. So let me do what? Pause share. How do I do this? Okay, I'll be right back. Okay, sorry about that. Okay, so this is explains about how to get some information out of these graphs. So I want you to do a lot of that in the Scrum. And then here, let's see. Let's just see what I said here. Oh, all right. Training versus testing. Can everyone hear this?
Yes, Professor.
Okay. And again, I'm looking at the images here. So let's look at some of these. So I just opened up, I just looked up training versus testing in Google and looked at the images. So this one. Oh, all right. So I looked up training versus testing here, found some images. This one I'm looking at. Here. So here's the full data. Okay, so what is it? Can somebody tell me what this picture is about?
Professor?
Yeah.
I think it's the process of splitting your data set into a training set and to a testing set.
Right.
And to create a prediction to see if the model is working or not.
That's right. That's exactly right. So I think we talked about this last week, I think. And so this is the entire data set. So maybe when we're talking about the iris data, maybe there's 150 rows of data in here. And then we're going to split it. So we're going to use part of it for training. That means to build the model. And then, so let's just quickly review that. So I'll open Explorer. And I'll open Weka. And I'll find the data. I apologize for the noise here. I was thinking about going to school to do this lecture, but I didn't do it. I go to here, and I go to Weka, and I go to the data. I'm going to do something here I'm going to do something dangerous here. So before I do that, I'm going to make somebody else a co-host, because what I'm going to do might crash my computer. And if I crash my computer, that will end the meeting unless I make somebody a co-host. So I'm going to do that right now. I'm going to make somebody a co-host. So who is the person who just talked to me? Tuan. See if I can find you. What's your name? Hi. I can't find that person in this list. Oh, there. Okay, I'm going to make somebody a co-host, because that will mean if my computer crashes, the meeting won't end. So what the reason I want to do something is that I want to open up this file. I guess we did this already, but I'll just do it again. So I want to find this file and open it up with Notepad++, just to show you that you should be doing things like this. So I have to find it. I have to go to here, and here, here, and for some reason my computer started crashing when I used Notepad++. So I don't know why. Never did that before. So let's see, Weka and data, and let's go to the iris data. So here it is. So I should be able to open it with Notepad++, but I can't. Or maybe I uninstalled it. It's not there. Let me see if I had Notepad++. No, I uninstalled it. Okay, let's just talk about how to install Notepad++. So let's go to here and here. and go to download. And I guess this one. Installer. And now it's installed. And then I open it. Okay, so that's as simple as that. Now if I go back to here, hopefully that will show up. Yeah, here, edit with Notepad++. I open it up. And here you can see this data file. Now this is not an Excel, obviously not an Excel file, and it doesn't look anything really like an Excel file. But up here, anything with, so the format for this file is Weka's own file format. You can see it's called .arff. I don't know what that stands for, but that's their own format. So in that format, if you want to add just a comment, you put this percentage sign in front. So all of this stuff here is just comments about the data down to here. So you can read about the data that therefore. So this data was created by this guy, which was quite a long time ago. Not so long ago, sorry. In 1988, R.A. Fisher was a famous statistician, and he created this data set. And when was it, where was it used? It says too many to mention. Here are just a few. So in 1936, he wrote a paper about it. 1973, he wrote a paper about it. And or someone wrote a paper about it, and so on. Anyway, it's a very popular data set, and more information about, more comments here, and attribute information, and sepal length is in centimeters, sepal width is in centimeters. And again, we are talking about iris. I don't know if I showed this before. Sepal. We are talking about a flower like this. I guess this is called the sepal here. So this would be like the sepal length and the sepal width. This is called the petal. This is called the petal length and the petal width. So we're talking about flowers like that. And there's versicolor, virginica is a different species, and setosa is a different species. So here tells us some information. Here's some summary statistics. So just like and we can get this out of Weka, but it says that the sepal length, the minimum, I guess, is 4.3, and the maximum is 7.9, and this mean is this, and the standard deviation is this, and so on. And then in Weka, the way you, so here, when the relation, I guess, somehow means the name of the data set. So it's called iris. And then when you want to have a new column or a new variable, you have to set it up like this. You have to say, you have to write attribute and then the name. So this would be the column name. And then you have to state the type of data it is. So is it numeric? Is it not numeric? When it's numeric, they use the word real, like real number, real number, real number, real number. So all of this is real number. And then the last attribute is called class. It's a categorical variable, and you have to mention the different possible values there. So that's the way you have to do this in Weka. And then here's the actual data. And that's it. So I'll close this, so maybe I didn't crash the computer yet. And so now I go back to here, and I go to the iris data set, By the way, this is Iris 2D. It means there's only 2 variables in this one. Let's just take a look at that. Weka 2D is here. So here you can see there's only 2 input variables, pedal length and pedal width. So it's just a reduced version of that original data set that he uses in an example. Okay, so here it is. Open it up. As we did before, we get this kind of display and this stuff. And if you wanted to, you can see this minimum, maximum, and so on. But we also said you can edit it here, and this is more like a spreadsheet view. Or if you actually want to save it as an Excel file or as a CSV file, comma, separated values file, you can do that too. You have to, it doesn't give you the right name here. I mean, the name thing sort of messes up there, but especially when you go to another here. So I think you just have to go like this. Iris, maybe, I think the CSV will be attached onto it. Let me click save. And now hopefully that is on the desktop. Yeah, there it is. And then of course, if you open it up, and that will open it in Excel, and you can see it as a spreadsheet. Okay, so that's the Weka format. It's called ARF, but you can get, used to be difficult to do this, but now you can get a CSV file easily. Okay, so going back to the here, going back to here. So we're putting so let's go back to here once more, sorry. So we said about training and testing, you go to here, you classify, and we can talk about percentage split. So 66%, that would mean that the training has 66% of the rows randomly selected, and this testing would have the other 34%. Okay, and then with the training, we build the model, and then we use the testing data in the model to get the testing predictions. Okay, now let's look at this. Here. So if I look at this one, look at this picture, just to understand this idea of a model before we go on to training and testing. So this is what we call a model. This green line is a model. So what is that? Okay, so does everyone understand that the green line is the model? So what are the blue dots?
They're instances?
Yeah, right. What does that mean? They're instances. That's correct. What does it mean?
Excuse me, professors, are they anomalies?
Are they anomalies? No, they're not anomalies. No, what she said it right. What they're instances. What do you mean they're instances? What does that mean?
They're each like instance of data, like each row, I guess.
Yeah, exactly. That's right. You know, that's the actual data. Those, like in our Weka data set, there would be, we said there were 150 rows, so we would have 150 dots. How many variables are being shown? Oh, sorry. How many inputs does Weka have? How many inputs does Weka have? Here's how many inputs does Weka have?
Is it 2?
Weka has 1, 2, 3, 4 input variables, right? Right, 1, 2, 3, 4, right? Everyone get that?
Yes.
Yes.
Everyone? Let me hear everybody's voice.
Yeah.
Yes.
Professor.
Yes. But Professor, I'm sorry. I thought it's called not input variable. I thought it's called num numeric variable. No?
You thought it's called numeric variable?
Yeah.
Yeah, that's true. It's also called, I mean, those are numeric variables, but in the model, we're what are we predicting in this, what are we predicting here? When I go to this and I do, suppose I do the J48, I'm not sure why Weka is so slow on my computer, but anyway, if I go here and I do the tree and I do it, so what am I predicting when I do this? I'm trying to predict the type of iris, right? Person who asked that question, you agree with me? I'm trying to predict the type of iris.
Yes, yes.
So this is what I'm predicting, the class, and I'm using these to predict this, right? Do you understand that?
Yes.
So these are called the input variables, and this is called the output variable.
Okay, I got it. Thank you.
Okay, anybody else? Okay, so how many input variables are there?
Four.
Four.
Right, and there's one output variable, right? So, but, okay, right? That's what we have, right? That's what we've been talking about. But here, how many input variables are there? Can anybody tell me? It's a little bit confusing.
Is it 2?
Okay, we have one vote for 2. Any more votes for 2?
There's only one.
There's one vote for 1. Any more votes for 1? Only 2 people are willing to vote.
Maybe 20?
3? Okay, 3. There's one for 3.
I think it's 2.
2. Okay, 2.
2.
Okay, 2, 3, 1.
I think it's 2 as well.
Okay, so we have to decide. Is it 1, 2, or 3? Okay, the answer is 1. What do I mean? Because if let's see, I have this new tool that I've been playing with. Fortunately, it's not very easy to use. If anybody is good with Notepad, I'm sorry, with this thing, OneNote, I'd like to know about it. Anyway, so, but let me try and use it anyway. So let's do this, draw ink to shape here. Do this. Oh no, sorry, not that. This shape one. And here. No, I do this one. Did I show you this tool before? This is pretty cool, actually, what I found. I'll just show you. This is kind of fun. Has nothing to do with what we're doing, but how many people have used this before? Anybody? Anybody use OneNote before?
I've used it a couple of times.
Yes, Professor.
Okay, some people know about it. Did I show you this before or no?
Not
Not
yet.
yet, no.
Okay, I'll just show you a trick that I found. So if I do data, this probably won't work, science. Then I do this. No, I do this. And I circle it. Okay, and then I do ink to shape. Sorry, ink to text. Oh, it worked. Okay, so now it made it into text, so it could read my handwriting. In other words, okay, that's not so great, but let's try this. Okay, and let's circle that. And now let's go this one. Okay, so it didn't work very well. Okay, I shouldn't waste time on this, but I'm just trying one more time. Let's just try 2x squared. I don't know if that's going to work. Plus 7y equals 10. Let me just try it one more time. Oh, bah. Doesn't read my writing. Before it worked well. I'll just do it one more. Let's try 2x plus y equals 10. Okay, let's see if it reads my writing now. Okay, so it worked. Now you can do things like if you, oh, I guess I could have done fix it, and I could have fixed this one maybe. Let me try that. Let's try that. Okay, so I think you can do fix it. What do you do? I don't know. Oh well. Okay, let's go back to the other one. Ah. Okay, it froze. Are you still there?
Yes.
Yes, Professor.
That app froze. That's not good. Maybe my computer. Are you still there?
Yes.
Yeah.
You can't get out of this. Okay, let's take a quick break. Don't go anywhere. Just take a break. I have to reboot my computer. Maybe I need a new computer. Okay, so I have to reboot mine because I can't get out of this, but at least I can talk to you. So I think since we have one, I reassigned somebody as the co-host, we should be able to come back without, but if there's a problem, we'll just have to, I'll have to restart the whole meeting again, I guess, but I think it will work. I won't have to, the meeting won't have to be restarted. I just have to come back into it. So I'll be back in a minute. Okay, can you hear me now?
Yes.
Okay, sorry about that. Let me just go back this one more time. I'm not going to do what I was trying to do, but I want to explain this idea, which is, okay, so here we have, so let's say we have our data. So we have data. So let's say we have sepal length, and let's suppose I'm from sepal length, I'm trying to predict sepal width. Okay, so I'm trying to predict sepal length from sepal length width. So that's not what we're usually doing. Usually we're trying to use all 4 variables to predict the class, right? Everyone know what I'm talking about?
To the APS students, because they have to like catch.
What?
You didn't share your screen, Professor.
Oh, I'm sorry. Okay, thank you. Okay, let me do that. Okay, so here's the here's a graph, and suppose we have sepal length, and suppose what I'm trying to do is take sepal length and predict sepal width. Okay, so that's not what we've been doing so far. Before, we were taking all 4 input variables and trying to predict the class, right? Everyone know what I'm talking about? No?
Yes, Professor.
Yeah, okay. So, but I want to just take one variable and predict this one variable. So this is the thing I'm trying to predict, not class. Not trying to predict class. Okay, so we have 150 rows of data, but we only have 2 columns. So we have sepal length predicting sepal width. So we have 1, 2, 3, 4, 5, 150 rows of data, right? So each row, so if let's say here I had 2, 3, that was 1 row of data. So let's say here is 2, and let's say here is 3. Then one of the flowers would be located here. Does everyone agree with that?
Yes.
And let's say, suppose I had 4, 1. So another flower would be like here, 4, 1. This would be another flower. And another row was like 2, 4. So there'd be another flower at 2, 4. Does everyone agree with this? So how many dots?
3.
How many dots will I have when I finish plotting everything?
3 dots.
Same
No.
as number of attributes,
dots.
instances,
What? Same as what?
Instances.
instances.
Yeah, number of instances. So suppose I had 150, there'd be 150 dots here, right? Everyone agree with that? If I had
Yes.
150 rows, then I'm going to have 150 dots. So each dot represents a flower, right? An instance, right?
Yes, Professor.
Okay. Now, suppose that we want to use, we said that we're going to break up, we're going to only use 66% for training, right? Everyone agree with that? So we're going to use 34% for testing, right?
Yes.
Okay. So in that case, we're not going to have, so 66%, let's say, equals 100 items or 100 instances, right? 100 instances. So then we're going to only have 100 dots here, right? Everyone agree with that?
Yes.
So what does it mean to build a model? It means that we want to come up with basically a function. So what are we trying to predict here? Sepal width. So I want to come up with a function that will predict sepal width, right? I want something that will predict sepal width. And we can say that the model is a function where we put in sepal length, and it tells me, oh, I think that the sepal width will be something. So like, okay, I put in a sepal width of 4, and then it's going to predict, okay, the sepal length is, I'm sorry, put in a sepal length of 4, and it's going to predict that the sepal width is whatever, 2 or something like that, right? You understand? That's the idea of a model. We put in our inputs, and we get out a prediction. Right? So everyone agree with that?
Yes, Professor.
We put in the input, could be input or input, and that's going to give us like the class prediction usually, the class. But in this case, I'm not predicting the class, I'm trying to predict the sepal width. So I'm going to put in the inputs, but there's only one input, sepal length, and I'm going to predict the sepal width. So we're going to get some predictions, right? For example, now the model we might represent the model by, for example, maybe a straight line. That wasn't a straight line, but anyway, by that. Okay, maybe that's the model. So that means, what does that mean? If that's the model, it means when I put in this value for sepal length, so that's a, let's say I put in 1.7 for sepal length, what's the model predict? Well, the way we figure it out from this picture is we just go over like that, and this would be the prediction, so maybe this is 2. Okay, and then if I put in like 2.1 into the model, what does it predict? So I'd go over to here, and the model would predict something over here. Maybe it's 2.8 or something like that. Okay, so this is a picture of the model. Does everyone get this idea?
Yes, Professor.
Now, what if we want to use more than 2 variables? You know, normally we're going to have many inputs, right? So not just one. In this case, I just said we're just going to have this one input, right? But that's not typical. Normally we have more. So let's say we had 2 inputs. So if I want to draw it, I'd have to do something like this, right? So like this would be, suppose I wanted to do sepal length and petal length, and I want to use that to predict sepal width. So this would be sepal length, and this might be petal length, and this would be sepal width. Okay, so this would say, okay, if sepal length was equal to 2 and petal length was equal to 3, what should we predict for sepal width? Well, I don't know. We have to build a model to make predictions. But suppose we built that model, then we would say that given 2, 3, we would predict a sepal width. So what does that mean in this picture? That means when sepal length is 2 and petal length, this is petal length, is 3, say here. So we'd go here, here, here. This would be the input, because this point has what coordinates? 2, 3, 2, 3. Okay, then what's the prediction for the steeple width? Well, I don't know what it's going to be, but say it predicted 5. Okay, so that what would that mean? It means that we go up to a height of 5, and we'd have a point up here. That would be the model prediction. That would be the model prediction. That wouldn't be the actual data. That's our prediction. That is this green line when we're only doing it in 2 dimensions. So anyway, this is too hard to think about. Or I mean, it's not that hard to think about, but you know, let's not deal with this. Let's just deal with a simple situation like this. Okay? So, but anyway, the problem is that to visualize what we really want to do, which is deal with 10 variables or 15 variables or 100 input variables, you can't do that. We have at most 3 dimensions to play with, and so this is the most we can do, is have 2 inputs and 1 output. Then we can visualize it in the normal way, but we can't do that once we go beyond 2 input variables. So anyway, we're just sticking with 1 input variable here because it's just easier to look at. So we have this picture, or going back to our other here. So, okay, so going back to here. Okay, so now let me ask you again. Let me ask you again. Okay, so here, how many input variables are there?
1.
1. And how many, of course, how many output variables are there? There's just 1. And what do the blue dots stand for?
Instances.
Instances. So how many are there? I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13.
20.
Okay, so there's 20 maybe. So there's 20. What's the difference between this picture and this picture? This is for these dots come from where?
Training.
Training set. These dots come from?
Testing.
Test set. So these dots here, training set, let's just pretend, let's say there's 66% here and 34% here, for example. That's just an example, but maybe it's like that. Okay, now, so can somebody give me an estimate of what the coordinates of this blue dot are? Just a rough estimate.
Minus 0.1 and minus 5. Sorry, minus 1.5 and minus 5.
Okay, maybe it's minus 0.8 here. Maybe this is 0.8 and minus 0.5, right? Something like that, right? Now, what does so that's the real data. Does everyone understand that's the real data? Okay, so there's say this is minus 0.8 and minus 0.5. So there must be that in our actual data set, right?
All right.
Okay, but what does the model actually predict when the x variable here is minus 0.8? What does the model predict? So the model predicts up here. The actual data was here, but the model predicts up here. The model doesn't have to be right. I mean, it could be wrong. And so we don't expect models to work perfectly. So the model doesn't predict exactly right, because the model predicts up here at the green level, which is almost 0, right? The height of here, if I go up to here, is almost 0, but the actual value here was about -5. Does everyone understand that?
Professor, we cannot see your
Oh,
mouse
God.
cursor.
Oh, yeah. You can't see what? Oh, you can't see my mouse?
Yeah.
Can you see the picture?
Yes.
Okay, you can't see my mouse. I don't know why that is. Oh, how annoying. Really? You can't see my mouse? That's most strange. Oh, well. Oh, that's terrible. Okay. Well, what should I do? Okay, I have to do this and hope that things work out. Oh, nothing's working.
Professor, maybe stop sharing and then start sharing again.
Maybe. Let's see. Okay. Stop sharing. And start sharing again. You mean before you could see my mouse, but now you can't?
Yes.
Okay. All right. Anyway, I have it here. So let me go back to here. So,
Professor, now we can see your mouth.
okay. All right. Okay, so let's go back to this point here. So I was talking about this point here. So what is the x coordinate? Okay, first of all, these blue dots are the real data, right? And the green is our model. So I forget what I said, but let's say we're trying to predict sepal width given sepal width is given sepal length. Okay, so this would be sepal length, and this would be sepal width. So suppose that the sepal length was here, which is minus 0.8, which doesn't make any sense, right? But suppose that was minus 0.8. Then the model predicts, then the actual value was over here, which is -4, say, or sorry, -6, say. Okay? So, of course, this doesn't make sense for sepal length and sepal width because you don't have minus numbers, but let's just go along with that. So we have minus 0.8, and the actual value for sepal width is -6, right? Okay, but what does the model predict? So the model says if this is minus 0.8, that you would go up to here and over to here, and that would be the prediction. Does everyone agree with that? So
Yes.
the actual value was here, but the model predicts here, right? So there's some error, right? This is the amount of error, or this is the amount of error, right? Maybe I should use a different color for error. This is the error, right? Does everyone agree with that?
Yes.
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 Model predicts up here, but the actual value is down here. So there's some error involved. Okay. So with that, let's continue with this.
Model.
Can you hear this?
This green line
Yes.
is a model. So what does that mean? Well, what is this picture? The blue dots are the actual data. So this data has a y value and an x value. It has only two variables in it. It only has one input and then the output. Now our data is not like that. Our data has 4 inputs, I think, and then the output, right? In our data, the output is not numeric, right? But this is an example, this picture.
That's another point. Is our, in the iris data, what's the output variable usually? Not in the example I just gave, but generally speaking?
Class.
It's the class, right? That's not a number, right? So that would be kind of weird to put on this axis in a way. Well, maybe not too weird, but it's not a number. But here in this example, it is a number. And for what we're trying to explain here, it's better to use a numerical output variable.
It's an example where the output is numeric. So it's a y-axis, which is a numeric axis, and it has, so each dot has a particular height, right? Each dot has a particular height, and that's its y value, right? So what we're looking, okay, so if you look at these dots, forget about all these lines in there, but if you look at these dots, would you say that there's a relationship between x and y? So what does it mean to say that there's a relationship? It means that if you know x, does that help you to know y? Right? That's what we mean by a relationship. For example, if we talk about people's ability in math and people's ability in physics, would you say there's a relationship between those two? That is, if you know somebody's math ability, would you suspect that you'd be able to better know what their physics ability is? In other words, if somebody has a low math ability, do you think you could say something about their physics ability? Probably, right? On the other hand, is there a relationship between people's math ability and their artistic skills? Maybe not as much, right? Not as much as the relationship between math and physics, right? Do you understand? So what we mean by relationship is if you know one of them, it helps you to know something about the other variable, right? So in this picture, if you know the x value of a dot, can you say, do you think that helps you in knowing the y value according to these dots here? What would you say? 0? I would say that there's generally an upward trend. Now you might say, but look at this and this. Okay, that's reasonable. But I'd still say there's a kind of upward trend. Okay? So, okay, you might argue that there's no help here. But I would say that if somebody if the x value is low, that the y value is lower. And if the x value is high, then sort of the y value is high. Okay, so I think there's some element of relationship here. Maybe it's not very strong, but there's something. Does everyone understand that? Okay, so a model is an attempt to find a relationship in the data. So that green line or that green curve is an attempt to do that. It's a kind of a model. It's a model. Okay? So I think that green line, okay, it's not always increasing, so that's probably why people wanted to say that there's not such a great relationship. It's not always increasing. It's not a straight line, but it's a more complicated model, we say, than simply a straight line, right? It has some curves in it. Okay, but it's a kind of a mathematical curve. It's probably a third degree equation. What does third degree mean? What does third degree equation mean? It means the exponent, the highest exponent in the equation is a 3, right?
So
like
I mean this.
y equals, a plus bx plus cx squared plus dx cubed. Right? So we know. Do I have to write that down?
Okay, so that's a third degree.
I try to avoid writing on the board because it doesn't. One, what should I say? Just one. I don't know what to say. But anyway, if you have a third degree, though, it can come back down. If you have a 4th degree, then it can come back up. Okay? So anyway.
So 3rd degree could look, 2nd
Anyway,
degree looks
the
like
green
that.
line is a kind
3rd
of a
degree could
model
look like
to
that.
fit the
4th
data.
degree could look like that.
Okay? And what that means is we can use that to make predictions about the y variable. That is, once we know x, we put it into that green equation. We don't know that equation, but if we knew that equation, we would take this value of 1, put it into the green equation, we would get this height. And then we would say that would be our prediction for the height. Now, it's not correct, right, according to the data, right? It doesn't perfectly predict the data, right? But it's better than nothing, okay? And then if you want at 1, you'd put that in here, and it doesn't, maybe it doesn't predict it perfectly, but it's better than nothing, okay? So that's the idea of a model. Okay, so this is a model of that data, all right? Okay, now going back to here. So we were looking at splitting our data. So what we're going to do is we're going to take the training data, not the testing data. So how much data is in the trainings data set? How many pieces of data? They usually say how many instances? 99. Okay, so we're going to take that data and we're going to use one of these algorithms to build a model. Now, in the picture that we just saw here, we're first of all, the data is different. This is not the same data. And also, we're using a kind of type of regression here probably. But all of the algorithms that we have actually build models of some sort. They may not look like this. You know, they might look kind of much more flexible. Neural networks are much more flexible than this, so they can get much closer to the actual data points. But we're going to build a model. Okay, does everyone understand basically what I'm saying? Okay, now, as I said, our data is different than this in an important way, and that is that it's the y variable, the thing we're trying to predict is not numeric in our data, right? So this is a different picture than this really. But the idea still applies. Okay? All right, now, so when we do multi-layer perceptron, we're going to build a model. Maybe we can't visualize it like we just did because the y variable is not numeric, so you can't do the same thing with it in terms of visualizing it. But we're still building a model to predict. Okay, is this clear? All right. So once we build the model, we'd like to know how good it is. Now we can do two things. We can say, okay, here's the training set. This is the training set, right? We build the model, and then we say, how good is it? Okay, by the way, how would you measure how good this is in terms of predicting the blue dots? How could you, come up with some measure of how good it is?
Okay, how about that? How would you come up with a measure for how good this model is?
Maybe find the standard deviation.
What is that? What do you mean by that?
Like the distance between the green line and the blue dots.
Right. That's exactly right. So she said that look at this distance here. Let's see. That distance, and this distance, and this distance, and this distance, and this distance, right? Those are all error. We can talk about those as errors, right? Does everyone agree with that? Errors in some sense. Now, it's funny to think about like here, for this one, would you say the error is positive or negative here? For this one, for this line here. Would you say the error is positive or negative? All right, let's not worry about that. Anyway, so we could talk about the error. And then what do? We could take the average error. Okay, so like this error is say equal to -3, and this error is +1, and this error is -1, and this error is +2. Everyone know what I'm talking about?
Yes, Professor.
And this error, is this error going to be plus or minus?
Plus.
Yes.
Plus, okay. So we could take all of those errors, we'll call them error 1 and error 2 and error 3, right? This is error 1 and this is error 2. And so we just add, and then we could like find the average of all of these errors. So that would mean like add them all up and then divide by the total number, right? And that would give us the average error. Does everyone understand that?
Yes.
The only problem with doing that is that you see that you're going to get some pluses and some minuses. And usually, not always, but usually I think when you add them all up, you're actually going to get 0. So that's no good. Because if you always get 0, then that's useless. Okay, so we don't quite want to do that. So instead we do something called the MSE. So that the E stands for the error. And what we do is we square the errors. And the reason we square them is because then we get rid of the the cancellation, the negatives and positives. So we square them, and then we take the mean. That's what the M is. So we can square all these errors and take their mean, and then at the end, I think we take the square root of that. And that I forget if we do that or not. But anyway, let's say we take the square root of it. So we do like this, the square root of it. So that is, otherwise we cancel, we get all the cancellation. So we don't want that. So we talk about the error as the one measure of the error is this thing called the MSE, the mean squared error. Okay, so that will tell us, how good the model is. If the mean squared error is very small, then it means the model was very good. Does everyone agree with that?
Yes, sir.
Okay. So.
What? I mean, looking at this picture, I want to say, how good is this model? Okay, let's just ask that question. How good is this model? So you can, let's say your answers could be bad, fair, good, and very good. So what would you say?
Fair.
Okay, I think fair might be
Bad?
okay.
Okay, somebody says bad.
Somebody might say
somebody
bad.
else says good, and so on, right? We all can have different answers, right? Because we don't have a concrete method for measuring it, right? So we can't necessarily agree. Okay, so how can we so-called measure it so that we have a way to say, oh, it's this now, right? We all will agree that it's this. It doesn't have to be that it's good, but just a number. We can say that the model is this good or this bad. Let's say it's this bad. So in other words, how can we measure the error? Let me move it to that question. How can we measure the error of this model? Yeah.
Okay, so somebody
That's
said
very
the mean
comfortable.
squared error.
Okay, good.
So they had already.
Right. He said how close the results are to what? To the green line, right? Yeah, that's the idea, isn't it? That's really what we're thinking about, right? When we say how good it is, right? How close are the dots to the green line, right? So how do we measure how close they are? Well, actually one way is you could measure the horizontal distance, but that's peculiar. That doesn't seem to make sense because the prediction is starting from here and predicting to here. So you wouldn't really go this way. You would go this way, right? So you can take the distances, right, of all the dots, right? Does everyone agree with that?
Okay, so
the vertical distances.
Let's go to here.
So how do we measure the error? We use the the squared errors, right? So you can see this MSE here. Okay, so that means this SE is squared error, and this means the mean of the squared error. Okay, so it's called the mean squared error. Okay, that's our going to make you much money, right? You want to use it to predict tomorrow's price, which measuring it on the training set. They want to, the goal.
Sorry about that.
However, data scientists say that's not proper. What's not proper? Okay, now.
All right, so the next question is, so should I decide how good the model is by looking at the error here or the error here?
Maybe at the test set.
Right. Why? Why?
Because we are testing it there.
Yeah, because I'm testing it there. Because we don't want to test the model on the same data that we use to build the model. Right? That's kind of cheating. Right? We want to see how it works on new data. We're not really interested in how it worked on the data from which the model was built. We want to, for example, well, let's just listen.
So we have our data. This is our training data. We get the model, and we can measure the error. However, data scientists say that's not proper. What's not proper about it? What's not proper about measuring it on the training set? They want to, the goal is to, once you have the model, the goal is to then use it on new data to, to make predictions, right? You build a model to predict the stock market. You don't want to use it to predict yesterday's price, do you? That's not very going to make you much money, right? You want to use it to predict tomorrow's price with new data, right? So it's not really proper to measure your model on the training set, right? You'd like to measure it on new data, okay? So we already made new data. We took out 51 pieces of data, right? They're not in there. We didn't, we just took them out. We didn't use that when we built the model, okay? So we can now use it as like new data. Wasn't used at all in the training, in building the model. Okay, does everyone get the idea? Okay, so that's the idea of splitting training and testing. Okay, and that's what we're doing here. And so that's the general paradigm. Now that wasn't really the way models were done before data science. So in statistics, they didn't really do that, as far as I know. Okay, they didn't split it. But that is the general paradigm now. Okay, does everyone get it? So if you talk to someone that doesn't know data science, they won't be really that familiar with this concept of training and testing. Okay? All right, anyway, we're going to split 66% for training and the rest for testing. So what's going to happen here when we run this model is it's going to build a model very quickly, instantaneously. Why instantaneously? Because it's a tiny data set. Okay? So it's going to build the model instantaneously, and then it's going to also test the model on the training data. And then we're going to look at the results of that, okay, of the testing on the testing set. Okay, so we can do that very quickly just by clicking Start. Okay, so let's try it, and it's done. Okay, so everyone see? Now we can ask, how well did it do? Now, what does it mean? This is different than this in terms of how well. Why is it different? Because, like I said, the prediction, the variable we're trying to predict, the output variable, is not numeric. So what does it mean to be correct or not? Like here, none of these are actually correct. Even this one is not correct. Even, you know, this one is not correct. Right? Correct is going to be impossible, basically, when you have numeric data, isn't it? You're never going to get exactly, you know, to the 10,000th decimal digit, to the 10,000th decimal digit. You're never going to get exactly right. You're never going to be perfectly on target. But that's not true now with what? With the iris data, where the variable is what? Is not numeric, it's categorical or nominal, it's called. In that case, you can be right. You're trying to predict, is it an iris setosa or not? So your prediction, you know, given the inputs, remember, we have testing data. The testing data has inputs. Each instance, we call it an instance, each row, each flower has, you know, sepal length, sepal width, and so on. It has those numbers, right? You're going to put those into the model and then ask it to predict, is it a virginica or is it a setosa or whatever, right? So it's either going to be right or wrong, right? It's going to be perfectly right or perfectly wrong, right? Not how close is it. Does everyone agree? It's a different problem, right? Working with numeric data is different than working with non-numeric data, right? It's a different thing, right? So we're going to be either right or wrong for each row of the testing set. Or they usually say for each instance of the testing set. Okay? So how do we measure how good it is in that case?
Okay, so how do we measure how good it is in that case?
Is it by the number of how many wrong predictions we have?
That's right. So we can just count up out of the, what was it, 49 elements in the test set, how many did we predict correctly, right? And how many did we predict incorrectly? So here, like I said, you're never going to be exactly correct for any instance. But that's not true when we have a categorical output variable. Then you're either going to be right or wrong, right? Does everyone agree with that?
Oh, yes, sir.
Okay, so if we look at, well, okay, let's keep going.
In the case of the irises, how do we measure how good we did, how good the model was? It's either right or wrong. There were how many rows or how many instances are there in our testing set? There are 51, right? Because there were 99 in the training. So there are 51 in the testing, right? So like the first one, it's gonna predict, oh, it was a setosa. And maybe it actually was a setosa. So then it would be right. The next row, it's going to predict it was a setosa, but maybe it was a virginica.
So we're talking about in the testing set, we're going to predict the first row should be a setosa. But in the testing set, we know actually what the first row actually was. We can predict, we can use the model to predict what the model says it will be, but we know what it actually is as well. So we can decide, was the model correct or not? Same thing with the second row of the testing set and so on. So we can just find out how many times we were right and how many times we were wrong.
So how do we measure how well the model does? Just count up. right? How many times did it get it right? And how many times did it get it wrong, right? It's a simple measure in that case,
Okay,
right?
I'm going to skip
They're
to
going to understand the
here.
measure of the model.
I'm going to skip to here
So,
because
do you see?
the question is, how well does Weka do, or does this multi-layer perceptron do? So if we go back here a little bit, we can see that it got 98% right. Does everyone see that?
Yes.
It got 50 of them right, and only one did it make a mistake. Now, if we go scroll down a little bit, we'll see this there. So let's quickly talk about this because I wanted to talk about this. We don't. So this is called the confusion matrix, and now in some presentations of the confusion matrix, if you look it up on Wikipedia, I think they have the rows and columns reversed. But here, in this one, the rows represent what the instance was classified as or predicted to be. And the columns. The columns represent what the instance was classified as or predicted to be. And the rows represent what it actually was. So what do I mean by that? Well, here's a 1. Does everyone see this 1?
Yeah.
Okay, what column is that in?
B.
B. And what row is it in?
Iris virginica.
C.
Right, it's in C, which C means Iris virginica, right? They just labeled them A, B, C. But C means Iris virginica, right? So this is what it actually is. So it's actually an Iris virginica. The column, is what the model predicts it to be. So what did the model predict it to be? B. What does B stand for?
Iris versicolor.
Right. So it was actually a virginica, but the model predicted what?
Versicolor.
Versicolor. Okay. Now how about, there were 15 in this category. What is this category? That means what was it actually? Or what were all 15 of these actually?
Setosa.
Setosa. And what were they predicted to be?
Setosa.
So that was not a mistake, right? Those were all correct. So these are 15 correct predictions. How about these 19? What are these? They were actually versicolor, and what does the model predict them to be? Versicolor. So they were also correct. What about these 16? What were they? They were actually virginica, and what were they predicted to be? Virginica. So anything in the diagonal here are correct predictions, and anything not on the diagonal are incorrect predictions. Does everyone understand that?
Yes, Professor.
So how many incorrect predictions are there?
One.
Just one. Just this one. So there's all these correct ones. That's what? 15 and 16 is 31 plus 19 is 50. So there are 50 correct and 1 incorrect. Does everyone see that?
Yes.
So if we go back here, that's what we said. There were 50 correct and 1 incorrect. Okay? But here we can see exactly where they were. Like there was only one mistake here. What was it? What? What was the mistake?
The prediction for Iris.
What? What did you say?
It predicts as Iris versicolor, even though that's like virgin.
Right, that's right. It predicted versicolor when in fact it was virginica. Okay, but there was only one mistake here. Now, normally, I mean, you don't get that doesn't usually happen. Like you might have something over here and you might have something over here. Like what would happen if there was a 2 right here? What would that mean? Can you see my mouse?
Professor, can you repeat your question, please?
What?
Can you repeat your question?
I can't hear you. Can you see my mouse?
Yes.
Okay, quickly. What would happen if there was a 2 here?
There will be 2 wrong on prediction.
What kind of wrong predictions?
It will predict Iris virginica when it was supposed to be Iris nodosa.
Right. So the 2 here would mean that it was actually a setosa. The row tells you what it actually is in Weka. Like I said, if you look in Wikipedia, it might be the opposite. It might have the actual up here. But anyway, here, if there was a 2 here, that means there were 2 iris setosas that were predicted to be virginica. Okay, so that's all for today. Okay, so I'll try to, so if there's still a problem with your group, please put a note and I will reassign the members. Okay? Okay, that's all for today.
Thank you, Professor.
Okay, good luck.
Thank you, Professor.
Professor, we don't
Thank you,
have
Professor.
attendance, right? Professor, I'm sorry, I have a question.
Yeah.
Do we have attendance or anything like that?
Today I didn't have time to take attendance.
Oh, I see, I see. Okay, thank you very much for the lesson.
I'll try to be taking attendance, but it depends. I have to figure out a way to do it quickly.
Okay, thank you.
Okay.
Professor, I have a question.
Yes.
So, one of the forums, you mentioned that if you have any questions regarding our homework, we can post over there. So I did not read the part where you said that not to answer the question per se. So, and someone did have a good reply to that. So is it okay if you like have any confusions to post it over there? Because if you're stuck, I can't really get help from any online sources or elsewhere. That's my only resort.
I'm sorry, can you say that? I couldn't hear it very clearly. You said something about Google Forms?
No, in the forum, like one of the forums that you posted.
Yeah.
There was one that deals with the homeworks and homework assignments.
Okay, let me look. Hold on. So the forums are here, right? And what about it?
Homework questions.
Ah, yeah. Okay.
So I posted a question there last night, and someone helped me out over there.
Yeah.
But I saw that you wrote that, like, if we're struggling to understand the meaning of the question, we can post it over there.
Right.
We need the answers.
Yeah.
So the person who helped me out over here, like, is it okay if we post answers like that? Because
well, I saw that last night, and then I thought, I don't really want everybody to tell everybody how to do the answers, but on the other hand, I do want people to tell everybody how to do the answers. I mean, I want people to learn. So I was torn when I saw that they gave you the answer, right? Sort of. And so I didn't know what to say. So finally, I just said good answer. But I wasn't sure what to say. Like my original purpose was to say, don't do that. But then he gave a good answer. So I wasn't sure. But anyway, what's your question now? I'm not quite sure what you want to know. I mean, what's your question?
would it be possible for you to upload your set of answers to the question?
Oh, yeah. I will do that, yes.
Thank you.
Yeah, okay.
Could you start with week 1 as well?
Yeah, I'll do that, yes.
Thank you, Professor.
Week 1. Okay, I will. Anybody else?